The next type that we're going to look at is BigInt. This is a newcomer to JavaScript and so even to TypeScript. BigInt is different from number types. Let's create a BigInt in JavaScript first and see how is it different from the number type. There are two methods to create a BigInt in JavaScript. The first way to create a BigInt is to use the constructor method. Let's create a BigInt by calling the BigInt constructor method first. So you can use the BigInt constructor method and pass either a string or an integer to it to create a BigInt. Another method to create BigInt in JavaScript is to use the literal syntax. Let's have a look at it as well. To create a BigInt using the literal syntax, you pass in an integer followed by a suffix of n. Now my IDE is throwing an error over here. Let's just look at what it says. It says BigInt literals are not available when targeting lower than ES 2020. So in our setup over here, we are targeting ES 2016 and we can get rid of this error by targeting ES 2020 for TypeScript compilation to JavaScript. And we can do this in the tsconfig file. So let's just open our tsconfig file and target the JavaScript compilation from TypeScript to ES 2020. This is my tsconfig file. And if you look here, we are targeting ES 2016. And let's just convert this to ES 2020. Now let's go back to our index.ts file. Now you see the error has gone away. This constructor function also creates a BigInt which looks similar to the literal syntax with a suffix of n at the end of the integer. Let's console log BigInt1 and see what's the result that we get from the BigInt constructor function. If you see over here, the constructor function also creates a BigInt with integer followed by the n character. So the question is that if numbers already existed in JavaScript, what was the need to introduce BigInts? It turns out that number type in JavaScript can only represent whole numbers up to 2 raised to the power of 53. It's unsafe to work with numbers beyond that range in JavaScript. Let me explain this with an example. Now it so happens that JavaScript defines the maximum safe integer as a constant, and I'm going to save that maximum safe integer possible in JavaScript in a constant and use it. Let me show you how. Now JavaScript has this max safe integer as a constant and is there on the number object. This constant returns the maximum safe integer that is possible in JavaScript. Let me log safe_int to the console and see what we get. This is the maximum safe integer that JavaScript allows as the number type. To understand why BigInt is needed and it's not safe to work with number types, let's try adding 1 and number 2 to this maximum possible integer and see what we get. So first, I'm going to add number 1 to safe_int. And now I'm going to declare another variable called safe_int plus 2 and add 2 to the safe_int as well. Now we have two variables, safe_int plus 1, which adds number 1 to the largest possible number in JavaScript, that is safe_int. And then we have safe_int plus 2, which adds 2 to the largest possible number, that is safe_int. Now I'm going to log both safe_int plus 1 and safe_int plus 2 to the console and see what we have in store for us. Now you see we get the same output even when we add 1 or we add number 2 to safe_int. This means JavaScript cannot go beyond this particular number when it comes to number types. This is the end of number types and this is equal to 2 to the power of 53. What's worse is that even if I try to do a conditional equation and check if saveint plus 1 is equal to saveint plus 2, it will return true. Let's try to do this. You see this returns true, which is not correct. So if you need to deal with a number that is larger than this maximum number and with precision, you would need to use BigInt. In order to declare BigInt in TypeScript, you just use the BigInt keyword while declaring your variable. This is how you would do it. Now I have declared a variable a, the type of that variable is BigInt, and I have used the BigInt constructor function in order to generate a BigInt in JavaScript. You can use the literal syntax as well as long as you're complying with ES 2020. This is an example of a literal syntax. Now this is what you can do with BigInt. You can use all mathematical operators, comparison operators, as well as conditional statements with BigInt. I will show you an example of a mathematical operator. Let's subtract the number a from number b and see what we get. So I have declared a third variable called c, which is again of the type BigInt, and subtracts a from b. Now TypeScript doesn't complain over here because it knows that type of a is a BigInt and type of b is also a BigInt. So the final result c will comply to BigInt as well. Now there are a few things that you can do with numbers but you can't do with BigInts. The first thing is that BigInts cannot have decimal values. So if you try to do something like this, it will not work. Now you see my IDE is already throwing an error. Let's look at those errors. So with BigInt, it says that decimal values cannot be used or the BigInt literal must be an integer. And over here, TypeScript also throws an error and it says that type number is not assignable to BigInt. So it understands that what we are assigning to it with a decimal is kind of a number and not BigInt. Now, apart from this, you cannot use the built-in math object with BigInts, which works with numbers. For example, let's try to use the math object and a method of math object on a BigInt and see what we get. Now here I'm using the math object and trying to calculate the logarithmic value of the BigInt a, but it throws an error, and let's see what the error says. Argument of type BigInt is not assignable to parameter of type number. So only number types would work with the math object and BigInts won't work with math object. I hope this is clear. This is all that you need to know about BigInts, and now we can move on to the next type. I'll see you in the next lecture.